I
You can pass it off.
I can do a quick intro and then I'll pass it to you. Yeah.
We're live already.
Hello,
Awesome.
everyone. Yeah, so well, welcome all the community member, and also this is a new hackathon workshop section, and today we're very lucky to have Zach from Chainlink. So it's like I don't really have to give an introduction for Chainlink because, well, it's like a very fundamental part of pretty much all the DeFi protocols. And yeah, Zach will be talking about a hybrid smart contract and Cronos. Yeah, I'll pass it to you, Zach.
Thanks so much for that introduction. You're too kind. I'll go ahead and share my screen. All right, you guys can see that, right? All right, so Awesome. Yes, so thanks for that introduction. And yeah, what are hybrid smart contracts? And how can we take advantage of them to take your development on Cronos to the next level? That's what we're going to be talking about today. So my name is Zach Ayesh. I'm a developer advocate at Chainlink Labs. And that just means I'm someone who helps engineers and really anyone building with a technology, in this case, Chainlink, be successful and make sure they have the best developer experience they can have. So we'll talk a little bit about what Chainlink is and the problems it solves, DeFi and Chainlink, Chainlink beyond price data, and where you can learn more. And then we'll do a little bit of demo so we can see how Chainlink works in a coding environment. So we'll start out with some fundamental definitions in case some people don't already know. So what is a blockchain? This is a very essential concept. A blockchain is a network of computers all around the world that store data and transaction in a shared ledger that isn't controlled by anyone. Essentially, you can think of it as a database that has been replicated over many computers all over the world and is secured by cryptography and game theory. Bitcoin is popularly known as one of the first blockchains. Blockchains can also run application code and be thought of as an application platform of sorts. For example, Cronos has a virtual machine, an EVM-based virtual machine that allows it to run programs. We should also lay down the foundation for contracts. You may already have an idea of what a contract is, but we can define it as a binding agreement between two or more parties, or more popularly, as we most know it, a legal document that can be enforced in a court of law. And contracts have been around for a long time. They started out being written on things like stone, evolved to paper. And eventually, we moved on through different technologies, telegraph agreements, telex machine-based agreements. And today, we're primarily in the age of digital agreements. Ever since the internet's been around, this has kind of been the primary way we do our contracts. And we're entering into the era of smart contracts. So let's focus in on those digital agreements. Again, digital agreements are the primary way we've done agreements for the past decade. And they're anything from bank agreements, so social media, Netflix, and crypto exchanges. They all have digital agreements that underpin their technologies. And you may notice a common aspect among all of these digital agreements is that there's really one party enforcing and executing and determining the outcome of these agreements. And those are the enterprises that created them to begin with. And because of this relationship, it's not really the relationship between these digital agreements and the users are not what everyone thinks they are. They can be very high risk and low control for the user, with some monopoly rents being extracted by institutions and big platforms. This could be a bad deal for some users. So we really call these traditional types of agreements paper or brand-based agreements, or digital agreements as well. And we're trusting these enterprises and companies to act in good faith act as the reputation has been in the past, continuing to act in the best case of the users. And the law isn't always there to help you. Lawsuits can be quite expensive, and enforcement of these contracts can cost users more money than they may be worth. So we have this brand-based trust, and if push comes to shove and chaotic market conditions, these agreements may not always come in as in the best favor of the users. So we're gonna zero in on a specific type of traditional digital agreement, CFI, or centralized finance. Finance products built on top of these agreements can work very well in predictable market conditions. But sometimes when conditions change and get a little bit more chaotic, this can change quite rapidly. An example I want to go into is Robinhood. If you're not familiar with Robinhood, Robinhood is a trading platform for equities like stocks. And it was thought that their digital agreement stated that users could buy or sell stocks at any time the market was open and at their preferred conditions. So a bunch of users decided to exercise this digital agreement to buy GameStop stock at the same time. Well, it turned out that Robinhood's digital agreement was not what their users expected. They blocked their users from buying the GameStop stock when they wanted to the most, despite what those users thought the digital agreement said. So we really cannot always expect CFI to support the average users, especially when conditions get a little crazy. So enter smart contracts, the next evolution of digital agreements. Smart contracts are self-executing contracts without the need of a third party. You can essentially think of them as code. Really, if you think about the Bitcoin blockchain, you can kind of think of it as like a proto or basic form of a smart contract where the code only allows the transfer of value. Then Ethereum came around and created generalized programmable blockchains with its EVM and allowed any form of smart contract to be coded on top of the blockchain. And today we have even newer blockchains like Cronos, which are pushing the boundaries of what blockchains and smart contracts can do. So today, smart contracts typically refer to code written on top of blockchains like Cronos. So what makes smart contracts the superior digital agreement? One is security and tamper-proofness. Many blockchains have been live for years without incident, and a well-designed smart contract cannot easily be changed after it's deployed. We have reliable and guaranteed execution. Remember, traditional agreements are executed and enforced by a party in an agreement who may not execute the terms of the contract immediately after those terms are met. In smart contracts, there is no party that controls when they're met. The code determines when the contract is executed. So an example of this would be in insurance. Sometimes the contract isn't immediately executed. Like, let's say you have crash insurance on your car. Rather, a lengthy and long review process could be initiated, and it could be months to years before that contract is paid out. Third is transparency. Traditional agreements can hide details from users in other systems. It can be very hard for an average user to go and see some traditional contracts that may be holed up somewhere in their bank. And this creates issues such as the 2008 financial crisis, where it was largely created by opaqueness in the financial system. Smart contracts have transparency of the agreement built in, and again, that enforcement is unavoidably built in as well. Trust minimization. Since neither party, there's reduced counterparty risk due to neither party having control over the execution of the agreement. So as in the Robinhood example, as an example, they could no longer stop people from trading unless it was coded into that smart contract, and that would be transparent for everyone to see. And 5 is efficiency. Due to all these things I described earlier, we can create more efficient automated business processes that save those businesses a lot of cost. Imagine how much money is spent on swaths of legal team and very senior programmers combining their expertise to make sure that these digital agreements are programmed properly and according to the law. With smart contracts, we can automate a lot of these processes. So smart contracts are great, but in order to understand Chainlink, we also have to come to the understanding that smart contracts are actually not as smart as we thought they were. They're not able to connect to external data outside of the blockchain. This is a big limiting factor for smart contract adoption, because it means really about the only thing that we can do in smart contracts is token transfers, transfers of ownership essentially on chain. You may be asking yourself, so why can't I just connect my the Cronos blockchain to an API? Well, blockchains are deterministic by nature. So all the nodes or computers running that blockchain software in the network have to come to agreement on the same values. And an API may return different values for different nodes, and that would break consensus. So if we look on the left diagram, we see left side of the diagram, we see a couple of Cronos nodes doing some basic math operations. And they easily come to agreement. 1 + 1 = 2, no matter where you are in the world. But on the right side, we have these same nodes connecting to an API. And maybe this API is calling the price of an asset, and the one on the bottom left calls it and gets the price of like 300. And then 1 second later, the top node gets a price of 301 because all this has happened asynchronously. Now they've received two different values, and the nodes can't reach consensus. They don't know which value is the true value. Thus, blockchains are unable to natively connect to the outside world. We're stuck validating value transfer and ownership of tokens without some sort of other mechanism. We need some sort of middleware to take care of this. And this brings in the solution. We need what's called an oracle. An oracle is a system that allows the blockchain and smart contracts on that blockchain to communicate with the off-chain world. For example, they could report the results of some kind of off-chain event or data on-chain so that the blockchain can stay deterministic. It acts as a sort of middleware between the blockchain and the outside world. Now, here's the thing. A naive way to design an oracle may be to make a centralized oracle, or a single oracle that just kind of gets all of our data and posts it on chain. But if a single node or entity controls this oracle, they can be corrupted, bribed, hack, or simply be malicious or acting in their own best interest to steal a lot of money. This is not good design for our users, especially when we have this awesome decentralized distributed software where we're putting our smart contracts on like Cronos. So to answer all this, we need a decentralized Oracle network, which Chainlink is. Chainlink is designed to be a modular decentralized Oracle network for connecting smart contracts to off-chain resources. So if we look at this diagram here, we can see on the left side, a bunch of Chainlink nodes gathering the price of an asset, communicating with each other to reach their own consensus, just kind of like a blockchain does, and posting all of their price views along with a final single consensus price on chain into a smart contract. This really creates a new paradigm of smart contracts, hybrid smart contracts. Now, by combining on-chain contract code with off-chain resources and oracles, we can really take the development of smart contracts to the next level. So we're no longer just on-chain code. Now with off-chain codes, the sky's the limit. We can really design a smart contract around any kind of idea that we want. And they're already starting to redefine the blockchain and smart contract industry. So let's dive in a little bit into Chainlink data feeds now. Real quick, before that, let's talk about what is DeFi, because this is an important definition. We talked about CeFi earlier, centralized finance. DeFi, on the other hand, is decentralized finance. We're essentially taking those CeFi digital agreements that were centralized and controlled and putting them onto a blockchain and to a smart contract and making it decentralized. So you can think of, any kind of financial contract on that's written as a smart contract, such as lending, borrowing, or exchanges as DeFi smart contracts. So Chainlink's DeFi solution are called data feeds. Some of the best node operators in the world have gone together and combined their prowess to create what we call reference contracts. These are decentralized on-chain reference points that can be considered kind of sources of truth for these various currency pairs. For example, you may have the price of ETH in terms of USD, for example, and that could be available on-chain for you to write DeFi smart contracts around. So in this diagram on the left, we have exchanges that have market makers that are determining the prices of assets on those exchanges. And right beside it to the right, you have the data providers. These aggregate some of these exchanges price points onto themselves and just open up APIs. On the right, we have Chainlink nodes, which each individually connect to the exchanges and data providers both to aggregate that data and come to their own points of truth. They then communicate with each other, like in that previous diagram I showed, to once again aggregate all of their data points to come to a definitive source of truth for that asset pair, and they can post it into those reference smart contracts that other user contracts can take advantage of. And we can actually see this happening live on data.chain.link. Let's go check it out. Okay, so we're on data.chain.link. And you can see right now we're looking at feeds on the Ethereum mainnet. And teams are working hard to soon have the Cronos mainnet on here, which will be awesome. But for now, we'll just browse on Ethereum. And we will let's look into the BTC USD price. So here you can see that process I just described. You can see all of the individual oracles that are working on this price feed and each individual price point and their logos and who they are. And we can see here in the top left, the final trusted answer that these nodes came to consensus for in the last round. We have what's called the heartbeat. This is how long the nodes, the minimum amount of time that must pass before the nodes have to update. And the deviation threshold, which if the node sense that the price of an asset is changing beyond a certain threshold, they'll automatically update regardless of how long it's been. You can see the last update was 18 minutes ago. All of the nodes replied. We can scroll down. We can see some price history for these assets and which nodes are posting on chain. And we can look at their Etherscan addresses and see all of that action they've been doing. So why are we stressing this point about decentralized Oracle networks? Well, there's already been attacks in this industry that to projects that have lost literally millions of dollars, and oftentimes these are due to insecure Oracle designs. We definitely do not want any developers or users to be losing money on some security risks. Chainlink has gone and started supporting the growth of DeFi across the industry. DeFi is constantly growing. We're super excited to see DeFi start really popping up on Cronos and to help empower those smart contracts to take them to the next level. We focused a lot on Chainlink and price data, but let's talk a little bit more about some other functions and services that Chainlink decentralized Oracle networks provide. So one important service is the Chainlink VRF, or Verifiable Randomness function, which is a service that allows the Chainlink network to provide randomness to blockchains. So remember earlier I was talking about how blockchains need to be deterministic and to come to consensus. This makes it very, very difficult to have randomness on chain in a secure way. There were some workarounds early in the smart contracting industry, but those are kind of insecure and gameable. Chainlink VRF generates a random number using some advanced cryptographic methods and provides a proof with that randomness before it posted on chain that the blockchain can then verify that this was in fact a randomly generated number. You can then have smart contracts that take advantage of this and in the most secure way possible. So where are we seeing this being used the most? Right now, this is being used a lot in gaming and NFTs. NFTs are super hot right now. I'm sure you've been hearing a lot about them. So you can use Chainlink VRF, for instance. Maybe you have a trading card NFT framework or a pack of cards you want to sell to users and give them very strong guarantees that they do in fact have 1 in 1,000 chance of getting that super rare card in the pack. Chainlink VRF can be used to request random numbers and give those users those very strong guarantees so they know that there isn't anyone kind of manipulating the price and not the price, but the randomness in the back end to work against them. Another awesome service is the Chainlink Keepers. This is one of the newest services that's been released. And so another limiting factor of smart contracts is they can't actually execute their own code without an external actor initiating this whole code. So Chainlink Keepers can utilize a decentralized Oracle network to actually to have them contracted out to run functions on the blockchain when given conditions are met. So an example of this can be thought of in DeFi with over-collateralized loans. So in DeFi, we have this concept, over-collateralized loans, where we take some kind of collateral, we lock them in a smart contract, and we take out a loan against that collateral. Now, the amount of collateral that's in that smart contract always has to be greater than the loan by a specified amount. Now, that changes via the from protocol to protocol. But once the collateral price of that asset falls below a certain threshold, the loan needs to be liquidated. And in the past, we've kind of relied on just anyone to come by and hopefully liquidate that loan. And that can work really well until, again, the market gets a little chaotic and gas prices go up. And you may just want to have some very strong guarantees that those liquidation functions are run when they're needed to run. And so we can contract out the Chainlink Keeper network to run those functions in a decentralized way. So we preserve that awesome tamper-proof properties that we had of those smart contracts. And finally, we have accessing any API. Chainlink can be used to integrate with any API, whether that's a web API, enterprise system, database, Internet of Things sensor, or API-enabled physical device such as a car. We had a very early hackathon winner who actually connected their Tesla to a smart contract using Chainlink and made some really cool features there where they could ride share their car, all in this cool decentralized way on the blockchain. Really fascinating. And any API I see as very useful, especially for like hackathon projects or anyone who wants to MVP their project. So of course, you can take any API and you can build up your own decentralized Oracle network, but any API is super useful if you just want to find a node. And if there isn't already a decentralized Oracle network for the data you need, use any API to kind of MVP your app before you go through all the effort of having a decentralized Oracle network made. So you can actually find all of these nodes that connect to these APIs and provide different jobs on a marketplace called market.link. So if we go on market.link right quick, you will see that, we have our data provider nodes. We can scroll up here, feeds, individual nodes we can look at on different chains, adapters that those nodes may use. So yeah, market.link is a very, very useful website to list your own node or to go on and find any nodes that you may want to use in your project. So let's talk about a little bit where you can learn some more about Chainlink if you want to continue after this talk. So a great place to go is the documentation at docs.chain.link. The docs are open source, and they really have everything that you could need to learn about developing with Chainlink. We have some tutorials like the beginner tutorial to advanced tutorial, which can take you from 0 to hero on using Chainlink, and a very easy step-by-step process. We have docs for each of the services provided that I talked about, and even docs on how to run your own node. And again, they're open source. So if you're reading the docs and you see something that you think could be explained better, or a feature you'd like to see added, or a typo, you can click on the GitHub symbol on the top right of the docs. It'll take you to a documentation repo. And feel free to make an issue or a pull request, and the team will review it and see if we can get it added in. Another great place is the Chainlink blog at blog.chain.link. These are for more long form, maybe more in-depth tutorials, explainer pieces. Maybe you were curious on how the Chainlink VRF works that I explained earlier, like what's the cryptography that's going on in the background there. There's a great article on that. Maybe you're just looking for ideas on what kind of smart contract you want to make, or hybrid smart contract you want to make on Cronos. So we have this awesome blog that I like to refer people to called the 77 use cases for smart contracts. And these just give you a lot of different industries and ideas of where smart contracts could come in and revolutionize those industries. And it's a great place to go if you're like, man, I know, hearing this, I feel inspired, and I know that I can do some great things with this technology, but I just can't put my fingers on what that will be. 77 use cases is a great blog to check out. And we also have our Solidity and smart contract starter kits. So if you're already a developer and you already have some experience, and you want to quickly automate the deployment of your smart contracts and write local tests, you can use these starter kits, Truffle, Hard Hat, and Brownie. If you're a JavaScript developer, you're going to want to look at Hard Hat or Truffle. If you're a Python developer, you're going to want to look at Brownie. And these are very, very powerful starter kits. They already come built in with all the Chainlink basic services and consumer contracts, have some basic tests, and are really just a great place to start off your project if you know you're going to connect your smart contract using Chainlink. We also have this really cool service in there called mocks, the mock contracts. So this may be really useful for any Cronos hackathon participants as since the data feeds for Chainlink are still in the works, you can use these mocks that are found in these starter kits, and we can look through them later when I get to the demo. But you can use these mocks to pretend like there's a Chainlink service right there, and you can create your smart contract as if you're connecting to a Chainlink data feed, as if you're connecting to a Chainlink VRF to demo any cool projects you may want to demo until those services are actually live on the mainnet and the test nets. So let's jump into some coding and go through some demos and see how we can actually use Chainlink on our smart contracts. So I'm going to try to go through Chainlink data feeds in any API, and if we have some time, also the VRF. So what I have is I have MetaMask installed, and this works obviously since Cronos is an EVM-based blockchain. All of these steps are just as relevant for those blockchains. MetaMask, I have some testnet ETH in that MetaMask, and testnet link in there as well, which we'll need for a couple of these services. And this link is actually out of date here. Everything can be, all of these testnet funds can be found at faucet.chain.link. Okay, so where I'm going to start is actually the docs. So I mentioned earlier, the docs have great step-by-step guides. So just to show you, come in here. And we're going to try to use data feeds. So we could actually go to using data feeds. But I'm going to go to tutorials and click on the basics. So if you're completely new to developing with smart contracts, or just have a little experience, this may be a great place to start. It'll walk you through everything from what is a smart contract to a little bit of introduction on Solidity, how they're designed, a lot of very good fundamental concepts, some of which we've talked in this presentation. And we come down and we see this example contract using Chainlink data feeds. So we got all this pre-made code, looks great. Some stuff that explains the code. And if we keep scrolling down, we have a button to deploy this contract using Remix. Let's go ahead and click that. Okay. This way here. We have our contract shown here. So at the very top of our contract, we have the pragma, which defines our Solidity version, and then we have our import statement. This is really the only thing you're going to really need to use Chainlink data feeds in your smart contract is the import statement. As you can see here, we're importing aggregator v3 interface.sol. And we've named this contract price consumer v3. And we define one state variable, aggregator v3 interface. That's the type. It's an internal variable, and we're calling this variable price feed. And our constructor will initialize that to whatever price feed or data feed we want to connect to. In this case, we're going to connect to the ETH/USD data feed on the Kovan testnet on Ethereum. And now we have one function, get latest price. This is going to call the latest round data method on our price feed. Let me zoom in a little bit, make sure this is clear. And we'll return a bunch of values here, round ID, price, started at timestamp. But the piece of data we really want is the price. So we're going to return price out of this function. Let's go ahead and deploy it. It's compiling fine. I have auto compiler turned on. Just some unused information, unused variable informational warnings, nothing that's stopping compilation. And we'll go ahead and go to our deploy and run transaction tab. We're going to switch to injected Web3. This will tell Remix to connect to our MetaMask. And you can see here, Kovan network popped up. So if I actually go and look at my MetaMask here, you will see I am indeed connected to Kovan testnet. And the great thing about MetaMask and EVM compatible blockchains like Cronos is that if you wanted to connect to Cronos blockchain, you would just have to change one simple config. You could go to custom RPC, put in the proper information, and you follow the same process and you're working on Cronos now. So we'll go ahead and keep it on Kovan. We're going to want to make sure we're pointing to the right contract. So we're going to point to price consumer v3, not the aggregator interface that we're importing. And we'll click deploy. Oh, click it one more time, see if MetaMask comes up. All right. We'll click confirm. We'll click on confirm on one. I clicked it twice, so that generated 2 transactions. And you can see here, my transaction was included in the blockchain, and my deployed contract can be seen here. And we have that get latest price method. So fingers crossed, this should bring up the latest price of ETH/USD. Let's see what it says. Bam, we got the latest price of ETH/USD as seen on the Kovan testnet. There's no decimal points because Solidity doesn't support floating point numbers. There's actually another method that tells you where the decimal should be in here, so you can program around that. But that's how simple it is to use Chainlink data feeds. It's one import statement. We can then get latest round data. And if we want to, we can make some awesome logic that revolved around the price of anything that came out of that data feed or any other piece of data that's written using data feeds. Okay. So let's go back to our docs and let's go now and let's check out any API. Go here, you see introduction, just gives us a introduction that I med. And we're gonna go to make a GET request. So this is a very common type of any API job that we're gonna wanna run. Kind of like data feeds, we're just gonna go request, send an HTTP GET request to some arbitrary API on the internet and parse the data and write some data onto the blockchain. You can see an important informational warning here. Remember, fund your contract with Link. We'll explain why you need to do that in this contract here in a second. So we see again our example code, and we can deploy this contract using Remix. Again, now that very same sample code is shown on Remix. This time we have a different import statement. We have Chainlink client.sol. This is what we need to import to use any API. And again, we're going to call this API consumer. We're going to inherit from Chainlink client. And we have a couple of state variables: volume, oracle, job ID, and fee. Volume is where we're going to write our data to when we make our request. We're going to get the volume of ETH/USD from cryptocompare.com. And we have oracle, job ID, and fee. These are related to who we're going to send the request to. So in this case, we're pinpointing a specific node again, like maybe a node that came off of that Chainlink Market. And so we need to know the address of that node. That's what the oracle is. And that node may do different job types. So we actually need to specify what job we're going to run. And every job has a very specific job ID that you can find on market.link. And finally, a fee. So since we are now requesting data from a single node, we're going to need to pay that node for its services. The feeds are paid for by the users and the sponsors who upkeep those feeds. So in the case of the any API, and the same goes for VRF, these kind of async workflows we're about to see, we need to pay the node operators in link token. So in our constructor, we tell it we call the set public Chainlink token, which finds the Chainlink token deployment on that chain. We initialize and point to the oracle we want to call and the job ID within that oracle we want it to run. And we define how much link token we want to send over to that oracle. In this case, our Oracle needs a 0.1 link. And now we have two methods, one for request volume data and another fulfill. So in request volume data, we're going to build up a request. In this case, we're going to say request.add. We're going to make a GET request to the free API for Crypto Compare. We're going to get the data that's returned from that API in the body, and we're going to parse the JSON object that came back. And we're going to tell it to follow this path in the JSON object raw.eth.usd, and then get to volume 24-hour and extract that data point. We're then going to multiply it by a constant, and then we're going to send off this request to the Chainlink node. The Chainlink node will get the request, it'll do all that magic, and then it's going to call a method that will eventually call fulfill. Well, it will send back the request ID of the request and the answer that you request from the node. And you can see here, it's going to take the volume then in this method when it calls it and store it within our state variable. All right, so let's go ahead. Again, everything is compiling okay. No red compiler errors. We will switch our environment to injected Web3. Make sure we're pointing at the right contract, in this case, API consumer, and deploy. Hit confirm, say we want to spend the gas. Again, this is all testnet funds, so no real money is being spent. And here we have our API consumer contract and those same methods that we show. We're never actually going to have to call fulfill. We actually can't due to the modifier that we are putting on our fulfill function, record Chainlink fulfillment. This limits it to the Oracle. So we're never going to need to call this method. If we look at volume right now, it's initialized at 0 as it should be. We didn't initialize it to anything yet. And yeah, let's go ahead and request that volume. Oh, you're going to see this error come up. Gas estimation error. Whenever you see this, this means that you did not fund your contract with link token. Remember, we have to pay that Oracle link token. And so that link token needs to be in our smart contract first that we deployed. So we're going to come to MetaMask and we're going to click send. We'll paste in the address of the contract that we copied right here from Remix. We'll say link. And I'll send in 0.3 link to be a little safe. MetaMask is going to do its MetaMask thing and estimate it as 0.2999. That's fine. We'll hit next. Give it a second and we'll click confirm our transaction. So we'll wait until that link is confirmed sent to our contract. This may take a second due to the miners having to mine the block. Great. So we just got included in. We should be good to go now if I click request volume.
So for the common user, they would be able to get it from the Chainlink faucet, I believe.
Exactly, yeah. And I can show you that faucet right after this.
Wonderful.
Yep. So yep, we'll go ahead and confirm our request volume transaction. Hit confirm. And now if we look, it's still 0 because we sent the request out to the API node, but now the API node has to do its work and it has to post its transaction on the blockchain, which it has to be mined as well, which can take a couple of seconds, maybe a minute or two max, usually not that long. Let's check one more time. And we have the volume already posted. So that's any API. And you see here, we could have made this anywhere to any source. We did talk about the faucet where we could find the Chainlink token if you want some testnet. So let's go ahead and go there. If we go to, we'll go back to the Chainlink docs actually. And we have developer reference here. We can click link token contracts. And for each network, we have, any API and our testnet link available. So, Cronos will be added here. In time, we will have, we can click on the faucet it'll take us to specifically that network, but we have a large selection of networks you can choose from. And so you can actually get link and sometimes even the native currency of that blockchain if we're running a faucet for that. But you can get link on each of these blockchains, and we can link to. We'll have links to any external party faucets you may need as well. So yeah, that's the faucet feature. And one other thing I wanted to show that maybe I mentioned earlier that could be very useful for anyone developing or developing projects in the Cronos Hackathon that wants to make use of Chainlink right now is the mocks and the starter kits. So if you go to GitHub, we'll go ahead and go to the main repo for Chainlink. This is the smart contract organizational repo. So at github.com/smart contract kit. And at the top, we have some pinned repos, and all of our starter kits are pinned up here. So we have Hard Hat and Truffle, if you like JavaScript again, and Chainlink Mix, which is the Brownie mix if you are a Python developer. If we go into Hard Hat, we go into contracts. So this will be the full repo right here. A lot of convenient instructions on how to run this repo locally, everything you need to set it up. And again, since Cronos is EVM compatible, getting the starter kit to connect to Cronos is as easy as just changing some values in the hardhat.config in this case. But we'll go into contracts, we'll go into test, and you can actually see our mock contracts. We have a mock oracle.sol, a mock aggregator, and a VRF coordinator mock. And if you want to run your smart contracts locally, these will auto deploy in our starter kits, and you can access these mocks and you can act as the VRF coordinator or the aggregator to test your smart contracts. I think this is a really powerful tool. It's also good for local testing. So that was the demo. Thanks for listening in and being interested in developing with Chainlink. We are an open source project, so again, everything's open and in the GitHub. If you're interested in seeing where we're at and what's going on, and if you want to contribute, you can also jump into our community. We have a vibrant Discord community where you can jump in and ask questions, talk with developers live, see what's going on. And we are also active on Stack Overflow. So if you're messing with any of these services and you run into any technical errors, you can go there. And again, we have the documentation as well, of course. So thanks again. And if we have time, we can open it for any questions anyone might have.
Yeah, thank you so much, Zach, for the very comprehensive introduction of Chainlink. I think it's definitely, the de facto solution, Oracle solution for all these different DeFi applications in on various blockchains. And we're very much hoping to see Cronos being supported in the due time. I guess one question I have is, obviously, we're seeing such rapid growth in the DeFi ecosystem with all these pieces composing to each other, building this money Lego, right? So which also creates certain issues, right? So when we have all these yield-bearing tokens that don't necessarily have an Oracle price feed support, say from Chainlink, then we see various hacks that happens with flash loan plus Oracle attack. What's your opinion on how protocols should think about dealing with this, and also in terms of the asset selection for their use case?
Yeah, the DeFi, money Legos, that's really what makes DeFi and these smart contracts so powerful, right? But it also can be a great weakness if you don't really look into it well enough, right? Because now we're introducing all of these different attack vectors. We're interacting with all these different protocols with different security. So it's very important, first of all, of course, to make sure you have your own security down tight. You know, in the blockchain world, once you deploy to mainnet, people will start moving funds in. You have to assume that money is just going to go in there immediately. And so you're going to want to make sure your security is top notch. Of course, that means running a Chainlink Oracle network if you require oracles, and getting your code audited properly, and just making sure that you're going to want to look at the other projects that you may be relying on. If you're a yield farming app, and seeing what security they have, what audits do they have the engineers really built those protocols with security in mind first? Are they using a Chainlink Oracle network for their Oracle? Or are they using some centralized Oracle that may be corrupted or hacked? Because if you're using them in your project and they are hacked, of course, that can affect your project as well. So really, it's just about doing tons of due diligence, doing a lot of work, and looking through the code, making sure that there's no gotchas yourself. Even if there's audits, I would look through every piece of code that I integrate with, make sure nothing is fishy there.
And how does Chainlink go about including more price feeds, especially with new tokens that are yield bearing?
Yeah, so data feeds are added as demand from the market dictates. And really anyone, if they want to, can make their own data feed. So that's what Chainlink is, an open technology. Anyone can grab the nodes and build up their own decentralized Oracle network if they want. That can be pretty tough. So they can also reach out to the Chainlink Labs team, and can reach out to node operators and help teams develop their any data feeds they may need to work with in their smart contracts. If anyone's interested in that, they can reach out to the Chainlink Labs team. They can reach out to me, and I can forward them to the right people to help them with that. Any other
Awesome.
questions?
Yeah, thanks. Leslie?
Yeah, I think I have a question on in general, I found that the developer experience with Chainlink is awesome. I would just like to know what is like the biggest challenge, and what is like the secret of providing this high quality, like top level developer experience. That may be something you can share with us.
Really appreciate the praise there. We work really hard to get the developer experience down. That's exactly what I work with. It's going to sound almost cliche, but just being out there and interacting with the users like every day. That's what we do as developer advocates. I'm very active in the Discord. I'm very active in Stack Overflow, and seeing the problems they're interacting with. We're constantly communicating back to the team when we see major points of friction in the developer experience, and we're seeing how we can improve that. And that may mean even helping out with other things outside of Chainlink, but could be still affecting Chainlink developers, developers using Chainlink, their developer experience. So for instance, recently, we're running a hackathon as well, and a lot of users want RinkB ETH, so they can, OpenSea, if they're doing an NFT project, OpenSea supports RinkB testnet. And the RinkB faucet has been a little finicky lately. Some developers we saw were having trouble accessing that faucet. So on one of the other developer advocates, Patrick Collins, he went out and figured out who was heading over the primary RinkB faucet, Peter, and they got into a discussion, and Peter was awesome and was willing to collaborate and sent a bunch of RinkB ETH over our way so we could run our own RinkB faucet to assure that our developers had the best experience. And I'm sure you all know, being in this space, it moves like every day. Like tomorrow, there's something new. Cronos is coming out. You guys are going to revolutionize the blockchain game. The space is moving super fast, and you just have to be in there and keeping up with all of it and seeing what the latest news is and seeing where people are going, and that can help you create an amazing developer experience.
Yeah, totally agree with that. It's like as you mentioned, the space has been growing, and then we got to catch up with new things every single day. And then I guess I'm similar as your position. It's like, okay, we got core developer actively developing new stuff, and then we would have to like communicate with the team as well, and then we would have to touch the ground and then talk to the user, the developer on Discord, and see what is like the most important question or like issue they have been facing. Yeah, totally agree with you. And
exactly.
Share the feeling. Yeah.
That's exactly, you totally got it there. And we also want to empower people to contribute, right? Like maybe not just use, but like also come in and contribute to this open protocol. And doesn't have to be just like a core set of developers. This is for everyone to develop with.
Yeah, and then we're trying to like smooth things out. It's not the case that people would not like to contribute. It's like sometimes, well, if they would like to spend like 2 hours to debug on something, and the passion gone, the fire dies off a little bit. Yeah, so it is like a challenging task because we would like to encourage this contribution from the community as well. But I think we're getting there.
Definitely, you're taking all the right steps. I can see it.
Awesome. That's my only like selfish question.
Great question. I really like that one. Had a lot to say there.
Yeah, we're also striving to build a very good developer experience, and very happy to collaborate with you guys and learn from your experience as well. I think with that, we're about time to conclude today's workshop. Again, thank you so much, Zach, for a super insightful introduction to Chainlink.
Yeah, thanks for having me, and I'm really looking forward to what your developers build on Cronos. See how they're going to push this industry forward, and see what awesome hybrid smart contracts they make on there.
Wonderful. Thanks, Zach, again. Yeah. So the hackathon is happening, and then please do check all the documentation that Zach provided on Chainlink. Very useful information. We will see everyone in the next workshop. Yeah. Catch you later.
Thank you so